Okay, let's do this question. This is 2010 MCQ number 4. The distance from the eye lens to the retina of a person is 1.7 centimeter. The focal length of the eye lens when the eye is in completely relaxed position is, they've given 5 answers as usual. So this is completely a biology question. This is not a physics question at all. So we don't need to calculate anything. So let's talk about some biology here. So our vision allows us to be aware of our surroundings. So 80% of everything we learn is through our sight. So the light enters the eye through the cornea. This is the clear dome-shaped surface that covers the front of the eye. From the cornea, the light passes through pupil. The iris, or the colored part of the eye, some people have brown, some people have blue, some people have green. Okay, so that part of the eye controls the amount of light passing through. From there, it then hits the lens. This is the clear structure inside the eye that focuses light rays onto retina. So next, light passes through the vitreous humor. Vitreous humor, this is the clear jelly-like substance that fills the center of the eye. It helps to keep the eye round in shape. Finally, the light reaches the retina. This is the light sensitive nerve layer that lines the back of the eye. Here the image is inverted. We need to form an image, and the only way you are going to form an image is with a convex lens. Now you recall when you were a child playing with magnifying glasses, and after a few minutes the paper would start to smoke and you'd burn a hole in a paper. Well, what it's actually done is it's formed an image of the sun. And because the rays of the sun, which have been essentially spread over the quite large area, have now been brought to a focus at one point. Not only has the light been concentrated, but the heat from the sun has also been concentrated as well. And that's why it gets very hot, and that's why it starts to burn. So the eye focuses light in a similar way to when you use a magnifying glass to concentrate the sun's rays onto a piece of paper. The distance from the magnifying glass to the piece of paper is the focal length. The eye focuses light in a similar way to when you use a magnifying glass to concentrate the sun's rays onto a piece of paper. So the distance from the magnifying lens to the piece of paper is the focal length. So the distance from your eye's lens to the retina is the focal length. When you focus an object in infinity, then the eye's focal length should increase, because in order to see an object from infinity, the focal length of the eyes should increase. So the ciliary muscles relaxes, so your eye lens becomes thin. Therefore, your focal length will be increased. So when an object is located at infinity, the focal length, or the distance from the cornea to the retina of a normal relaxed eye, is about 17 millimeter. In other words, 1.7 centimeter. So this is pure biology. So there are no calculations involved in it. It's a straight direct question. So it's worth noting that at near vision, you see, for near vision, the ciliary muscle contracts, so the lens thickness increases. That's what we call accommodated lens. so it'll be more spherical. So more spherical mean greater focus power. So greater focus power mean less focal length. So for distance vision, normally distance vision usually at infinity. So the ciliary muscle relaxes, so the lens thickness decreases. So this is what we called unaccommodated lens. Okay, so it looks like flatter, in thin shape. Okay, so lesser focus power mean greater focal length. So the greater focal length is the distance between the lens and the retina. So that is 1.7 centimeter.